now. So we will be recording this session. If anybody has any objections with regards to recording, then please say so now. 4, 3, 2, 1, and we are good to go. Okay, so the next 3 topics, at least 2 of these topics we're going to be seeing today, these are topics that you should have seen at some point before in any in a math course before, probably in high school. And so these aren't really new topics for you guys. So we're going to approach them directly and going into solving some problems here. And so we're talking about functions, and the types of functions that we're talking about right now are power functions. And remember that a power function is a function where I've got a variable x, and that variable is elevated to a certain power. And so 2 types of these power functions have particular characteristics, and the first one is the linear function or the line function. The line function basically has 2 modalities. Okay, a line function can be a constant function where I've got f of x equals b. So for example, if I have a function that is of the type f of x, for example, equals 3, then that's a type of linear function, because this linear function is a function that is a straight line, but it is a horizontal straight line. So f of x equals 3 would be a horizontal line that goes through 3. And then there's the more general form of a linear function, which is f of x equals ax plus b, where a and b are constants. And obviously a is different than 0. So for example, I can have a function that's of the form f of x equals, I don't know, 2x plus 1. And this could be an example of a linear function in a more general form. Okay. And in the case of 2x plus 1, if we were to graph that, it would be a function that goes something like this. It would be a line. If you notice here and try to link the things that we've been talking about, the plus 1 means that this function is a y equals x function that's been moved up, so it's a shift up. Okay, and the 2 means it's a compression. It's a stretch. Okay, of the function. Okay, the domain of a linear function, the domain is always going to be from minus infinite to infinite. Okay, the domain of a linear function is always going to be that. And there's another concept here that's very important, that is the slope of a function. Okay, let me just move this over here. Okay, the slope of a function is going to give us kind of the indication of the inclination of the linear function. Okay, and the slope is called, or we reference it usually with the letter m. Okay, and m is going to represent this sort of inclination, and it's going to be the relationship between the change in y with regards to the change in x. The change in y is called the rise, and the change in x is called the run. And so the rise divided by the run is what we're going to be calling the slope. And again, the slope is going to give us this indication as towards, or with regards to the inclination that a line has. Okay, and these are examples of linear functions, and examples of slopes. And the slope given a linear function and placing any 2 points in the linear function, let's call this x1, y1 and x2, y2, the slope is going to be the difference in the relationship between y and x, which is the rise and the run. So if we want to calculate the slope, it's going to be y2 minus y1 divided by x2 minus x1. And so notice that In the case of A, the slope is positive, okay? So that means that it's going it has a certain inclination. That means it's going from from negative to positive. If we were to go from left to right. Then in the second case, the slope is negative. So we see that the inclination is towards the other side, going from positive to negative. In the case of the slope being zero, the slope being zero means a completely horizontal line. And if the slope is undefined, it means it's a straight vertical line. Okay, so those are going to be the characteristics of the slope of a function. Okay. Okay. You were asking, I think Andrea, right? You were asking about these two cases here, Andrea. Which one?
Yes, on the third one and the fourth one. What did you say?
Okay, so let's look at the formula here for the slope. So for the slope is going to be the difference in the relationship between the y and the x. It's going to give us the inclination. So if the slope is zero, it means there's no inclination in y because y2 minus y1 is zero. Okay, so when the slope is zero, we're talking about a completely horizontal line. Okay, it has no inclination. Okay, when the slope is undefined or infinite, that there means that the denominator here, x2 minus x1, is zero. And this means that the slope is the slope of the line is infinite or undefined, and that means it's a completely vertical line. So these are two special cases of the slope where when the slope is zero, the line is going to be completely horizontal. When the slope is undefined, the line is going to be completely vertical. Okay, those are two special cases. If it's not zero or infinite, it means that the line has some sort of inclination. Okay, does that answer the question?
Yes, thank you.
Okay, good. Now, there are some general, in the case of these functions that we're looking at, particularly the line function, there are certain general representations of the function. And so there is one representation that we call the point slope equation. So always when we have a line, we're talking about a line function, we can define the mathematical expression of a line function with two data points. If we have two coordinates, coordinate 1 and coordinate 2, we can define the mathematical expression of the function. But also if we have the slope and 1 point, we can also define the equation for the line. So if we've got the slope and a coordinate x1, y1, then the general formula or the point slope equation is given by y minus y1 equals mx minus x1. And in this case, the slope is going to be the relationship between y and x. There's another general representation that's called the slope intercept equation. And the only difference between the point slope equation and the slope intercept is that we know the slope and we also know where the line crosses in y. Okay, we know where the line crosses in the y-axis. That coordinate is going to be given by 0, comma b, and in this case, the equation or the expression is given by y equals mx plus b. So whenever we're going to define a line or a line function, we only need two data points. We can have two coordinates, we can have the slope in a coordinate, and in some cases that coordinate can be the coordinate that that crosses the y-axis. That can be a specific value that we can include, and we can represent it any of these ways. Now let's look at another characteristic of lines, another important characteristic of lines, and it has to do with lines that are parallel and lines that are perpendicular. Okay, so a parallel line, or when two lines are parallel, that means that those lines are never going to cross. Okay, so if we look at the XY plane, we've got two lines that are parallel, And that means that the lines are never going to cross. And for this to happen, for two lines to be parallel, or for two lines in the XY coordinate to never cross, their slopes have to be identical. Okay, so we know that two lines are parallel when their slopes are the same. So if I've got line 1 and line 2, line 1 has a slope of m1 and line 2 has a slope of m2. If the slopes for those two lines are the same, then the lines are parallel. Okay. Now, and these are examples. Now, another situation is when lines are perpendicular. So what is a line that's perpendicular? A line that's perpendicular are two lines that are perpendicular to each other are lines that cross. So these are lines that are going to intersect. However, the intersection, this intersection that's generated here, what is the angle that's generated in that intersection? For this particular case, if the lines are perpendicular. Can somebody tell me?
90 degrees.
90 degrees, correct. Thank you, Estrella. So for a perpendicular line, the angle of the intersection is 90 degrees. Okay. Lines that intersect and the intersection generates a 90-degree angle, those lines are perpendicular. And there's a relationship between the slopes of two perpendicular lines. Okay. The slopes for two perpendicular lines have the following relationship. The multiplication of the two slopes equals -1, or another way of saying this, if I've got slope 1 and slope 2, the relationship is that one slope is the negative reciprocal of the other slope. Okay, so it's reciprocal, so it's divided by that number, and it's negative. Okay, so an example of two parallel lines would be, for example, if M1 equals 2, then for the lines to be parallel, what would M2 have to be equal to? If
4?
the line, excuse me?
4?
No, what does this say here?
It has to be 2 for it to be parallel.
Exactly. For them to be parallel, the two slopes have to be identical. Okay? That means that these are parallel. Now, for the two slopes to be, or the two lines to be perpendicular, if M1 equals 2, then what would M2?
-2.
Nope.
No?
-3.
Nope. There's a lot of real numbers in the real line, in the real number line. So if we go through them, we're never going to finish. Okay. The first answer was partially correct. It's negative, but what does it say here? If M1 is 2, then the other one has to be? What do we have here?
-1/2.
-1/2. Correct, Andrea. So when we have parallel lines, the two slopes are identical. When we have perpendicular lines, it's going to be the reciprocal. So 1 divided by the number and negative. Okay. So remember that. You're going to be doing some exercises regarding that. And it's important to remember these relationships between the slopes. So basically, the slope is going to give us, or the slope of the lines are going to give us information regarding this characteristic, if they're parallel or if they're perpendicular. Okay. Questions with this before we do some exercises?
No.
Okay. Let's go ahead then. Okay, let's look at these two examples. The first one, find an equation for a line with slope 6 that goes through -1/2, 2. We want to find the expression for that line. So I'm going to switch over here to the canvas, okay? And for example 1, it says that the slope is how much?
6.
6. And we have one coordinate that we're given. That coordinate, which is x1, I'm going to call it x1, y1. What is the coordinate we're given?
Minus a half, comma 2.
Correct. Thank you. Minus 1/2, comma 2. And so, given the slope and a coordinate, I can find the expression, the mathematical expression for that line. Remember, we only need two data points of information. How do we find that? Well, we've got an expression that says that y minus y1 equals m multiplied by x minus x1. You can always use this expression to find the mathematical expression of a line. So what do? We're going to substitute the values we've got here. And so y minus y1, what is the value of y1? It's 2. Equals the slope, which is 6, multiplied by x minus x1, but x1 is minus 1/2, so we have to be careful of the signs there. Okay, and so this gives us y minus 2 equals 6. I'm going to multiply this minus by this minus, and it's going to be x plus 1/2. And then I'm just going to multiply and organize things so I leave it as a function meaning y equals something, okay? And so this is going to be equal to y minus 2 equals 6 times x is 6x. And 6 times 1/2 equals 3. And lastly, y is going to equal 6x plus 3 plus 2. And this is going to give me my equation, which is y equals 6x plus 5. Okay. And that expression, or this expression here, represents the line that complies with these two characteristics. Okay? Questions with this one?
That will be the answer.
Mm-hmm.
Okay. Let's find that equation. Thank you.
Yep. So basically define the equation that represents the line that has these characteristics. There's going to be a bunch of problems. I suggest you start doing them as soon as possible. In the first section of problems in the homework task has to do with this. They're going to give you a slope and a point. They're going to give you 2 points. They're going to give you data, and they're going to say, find the equation for the line that satisfies these requirements. Okay? It's basically to practice these concepts. Okay. Questions with this one before we move on to the next one?
No.
Okay. Okay, so I am going to clear this in 5, 4, 3, 2, 1. Now let's go to the second problem. What does the second problem say? Help me out there so I don't have to change the screen.
It says find an equation for a line passing through points 4, 3 and -2, 5.
Okay, so now we're given two coordinates, okay? So one coordinate is going to be x1, y1. And could you repeat the first coordinate, please, somebody?
Is 4,3.
4, 3, correct, thank you. And then we've got another coordinate. I'm going to call that one x2, y2. And this coordinate is going to be
Minus 2,5.
minus 2, 5. Okay, so now we're given two coordinates. So remember that we've got a couple of expressions there that we can use here. So the first thing is that we can find the slope. And remember that we've got an expression for the slope that says that the slope of the line is going to be y2 minus y1 divided by x2 minus x1, okay? And so let's use these 2 points to find the slope, okay? So, by the way, I was given 2 points. I'm saying that the first point is 4, 3, and the second point is minus 2, 5, just because that was the order I was given in the problem. It doesn't matter which one you designate as 1 and 2, okay? You're going to get exactly the same result if you would have said that x1, y1 was minus 2, 5, and x2, y2 is 4, 3. It doesn't matter the order of the points. You're going to get the same result as long as you apply them congruently in the formula. Okay, so here we're going to have y2 minus y1, so it's 5 minus 3. And in the denominator, we're going to have x2, which is minus 2 minus 4. Okay, and this is going to give us 5 minus 3 is 2. Minus 2 minus 4 is minus 6. And so this means that this is going to be minus 1/3. Okay, that's going to be the slope. Okay. Now we've got another data point here, which is the slope. So now we know that m equals minus 1/3, and we can find the expression or the mathematical expression using the slope and using any of these 2 points. We can use any one of them. It doesn't matter. I called this one x1, y1, but we could use any of the 2 points to find the equation. And again, we're going to be using y minus y1 equals m x minus x1. Okay, and so we've got the expression here. So y minus, I'm going to use the first one, y minus 3 equals m, which is minus 1/3, and x minus x1, which is 4 in this case. Okay. This is going to be equal to y equals minus x divided by 3 minus or plus 4/3 plus 3. And so this is going to be equal to y equals minus x divided by 3. And joining these through to here is 3 times 3 is 9, plus 4 is
is 13/3, I think.
Perfect, thank you. Under 13/3. Okay, and this would be the mathematical expression or the equation there. Okay. Okay, questions with this one?
So to get the equation, we always have to use the formula that's in blue, the second blue.
Yes, actually, you can use this formula, or there's actually a variation of the same formula, which is literally the same formula, but just combined, that instead of putting m here, if you're given the 2 points directly, you can also say y2 minus y1 divided by x2 minus x1 multiplied by x minus x1. So you can use the blue one or the purple one, or use the first to find the slope and then use the blue one here. Any combination of expressions you want to use, you can use to find the mathematical expression of a line. But it's very important that you always need 2 data points, okay? You either need 2 coordinates, the coordinate and a slope. You need 2 things to be able to find the expression of a line, okay? If you only have one thing, then you're missing something.
Okay, thanks.
Okay, thank you. Questions with this one before we move along?
No.
Okay, I'm gonna clear in 5.
Professor, yes.
Yes, go ahead.
It's the same if I let the minus 1/3 x, or you want us to put minus x.
No, it would also be correct, Andrea, if you said minus 1/3 of x plus 13/3. That would also be correct.
Okay, thank you.
Yep, it's correct. The important thing in the expression is we have to have y equals the expression there. So yeah, any of those is correct.
Teacher, I have a question.
Yes, go ahead. Yesel?
Yes.
Yes, go ahead, Yesel.
Can the function does the y have to be alone? For example, it can be like 3y equals minus x plus 13.
That's a good question. Yes, Yesel. So if we're representing the line as a function, we want y equals something. Okay. Yeah. So it would be, let's say, because you could multiply by 3, which is basically what you were saying, multiply by 3, so the x doesn't have the 1/3 here. You could do that, but that wouldn't be a correct representation of y as a function. Okay. Okay, good. So I'm going to clear this and I'm going to go back to the PowerPoint. Okay. And now we're going to be talking about another type of power function, which is the quadratic equation. So a quadratic equation is going to be a function in the form of ax squared plus bx plus c, where a, b, and c are constants. And a is different than 0. And this is obvious because if a was 0, then this would automatically turn into a linear function. So it's important that the highest power we have is x to the square. Okay. The domain, and this is called a quadratic function. And quadratic functions also have certain characteristics that are important to note. The domain of a quadratic function is going to be from minus infinite to infinite, always. Okay. Now, quadratic functions have something that are called roots. Okay. They have something that are called roots. The roots of a quadratic function, and by the way, we've already been using this. Remember that we use them in inequalities. when we had a nonlinear inequality, we had to find the roots. The roots were the values that we obtain when we make the function equal to 0. And also another thing that's important is that the roots of a function are going to be the x-intercepts. They're going to be the points where the function crosses the x-axis. And so particularly for a quadratic function, there's something that's called the general formula. Okay, so the general formula is going to be this expression that given A, B, and C, we are able to find the roots. So this is a typical formula that you should already know, minus b plus minus the square root of b squared minus 4ac divided by 2a. This is a general formula. Sometimes when we're looking at a quadratic expression, we don't need to use the general formula because we can factor it. We can directly identify that the function can be factored. If the function can be factored, then that's fine. But if we don't want to bother factoring the equation, we can always use the general formula. Okay. Now, the equation of a quadratic function can be represented also many ways. This is the general, or what's also called the canonic representation of a general function. This one here. But another way of representing the quadratic function is also this way here, where we basically have a value a, we have these two values here, h and k, which are called the coordinates to the vertex. And the vertex is going to be an important thing in a quadratic equation because it's going to represent either the maximum or the minimum value of the quadratic equation, depending on how it's represented. So that's another way of representing a quadratic expression. In the case of a quadratic function, the graph of a quadratic function is called a parabola. And it's very easy to know in what direction the parabola goes, because if we have a parabola, the value of a, if it's larger than 0, I'll be with you in a moment, Diego. If the parabola, the value of a is larger than 0 or positive, the one that's with the x squared, the parabola is facing upwards. If the value of a is less than 0 or negative, the parabola is facing downwards. Yes, please go ahead, Diego.
Can you put the last slide? I want to
Yes.
see the formula.
Yes, of course. There we go. Okay, you have a question there, Diego?
No, I was just writing the last formula.
Oh, okay. Yes, go ahead. Remember that all of this is in the Blackboard presentations. If you need me to stop to write something down, then please let me know, like Diego did. Okay. Okay. Let me know when we can go to the next slide, Diego.
Yeah, I already read it down.
Okay. Perfect. Thank you, Diego. And we'll go to break in a minute. And so if a, which is the value that's next to the x squared, is positive, the parabola is facing upwards. If a is negative, the parabola is facing downwards. Okay. And the point h comma k that we saw in the vertex representation is going to represent either the highest point or the lowest point, depending on how the parabola is facing. The parabola is always going to be symmetric with regards to an imaginary line that goes through the vertex. So if we were to draw an imaginary line that goes through the coordinate h comma k, the parabola is always going to be symmetrical to that line. Okay. Okay, so again, we've got now this expression here, and we want to graph it or sketch the graph of it. We know that it is a parabola, and we know that the parabola is facing upwards because the value that's here in the x is positive, the x squared, okay? So let's just extract some information here, and I'm going to do this problem in a very systematic way so you can try to maybe understand all the steps and maybe replicate some things here. But we know that what is the value, if this were a general representation of a parabola, which is a x squared plus bx plus c, then what is the value of a? Somebody tell me what the value of a is.
1.
1. Okay. What is the value of b?
-2.
-2, correct. And what is the value of c?
-3.
-3. Okay. Now, another thing, is it possible to, let's find the intercepts. And how do we find the intercepts? We are going to find the roots of the function, okay? And how do we find the roots? We need to make the function equal to 0, okay? Is there, so x squared minus 2x minus 3 is going to be equal to 0. Can we factor that expression?
Yes.
Okay. I want you guys to do the following. So apparently we can factor it, but just as an exercise, take these 3 values here and use the general formula to find the roots. And you should get the same values we're getting over here. So we can factor it. Can somebody tell me the factors, please?
-3 and 1.
-3, x minus 3, and x plus 1. Is that correct for everybody?
Yes.
And so that means that the roots are x equals 3 and x equals -1. Okay? Is that clear to everybody? So now we've got a better idea as to how to sketch this parabola. Okay? And how are we going to do that? I'm going to draw an XY plane over here. And what does this mean? This means that our parabola crosses in x equals 3. So roughly around here, we're going to say 1, 2, 3. And it also crosses in x equals -1. Okay? So from that information, we know that the parabola crosses in those 2 points, and we know that the parabola is facing upwards. So at this point, we can say that our parabola should look something like this. And I'm just doing a rough sketch here. Okay? That would be our parabola. Okay? Are we okay up to this point? Questions up to here?
We don't have to
No.
check if it has y-intercepts.
We can find them if we want. We can find them if we want. How would we find the intercepts?
F of 0.
Let's do that. That's a good thing. These are what we just found here. These are these here, the roots are the x intercepts. Now, if we want to find the y-intercepts, I'm going to do that in a different color. The y-intercepts are going to be, I'm going to do them over here. How do we find the y-intercepts? We make x equal 0. So y is going to be equal to 0 elevated to the square minus 2 times 0 minus 3. So the y-intercept is going to be in minus 3. This is the y-intercept. And so that's interesting. So let's add a bit more detail to our graph. Now we know that the y-intercept is in minus 3. So this means that we've got a 1, a 2, and a 3. We've got a minus 3 here. And that means that somehow the graph has to go through here. Okay. So we can add a bit more detail here. The graph goes here, it crosses here, and then it goes up. Okay, very good. I think it was it Viviana?
Yes.
Yeah, very good, Viviana. Very good catch, very good observation. So now we've got a bit more detail to the graph, okay, to the sketch. Now, there's one thing that would be useful also to find here in the graph, okay? And what would also be useful to know, just to have even more detail to the graph? Can somebody tell me? I know where it crosses in X and I know where it crosses in Y. Do I know the value of this point here? What is this point called?
The
The
vertex.
Vertex. So we don't know the value of the vertex. And it would be very useful to have that value, okay? We don't know that value. Let's try to find it, okay? And how do we find the value of the vertex? Well, we're gonna do a procedure here to do that. I'm going to, is it okay if I erase this part here where we did the roots and the y-intercept, the green and the blue? Is that okay?
Yes.
Yes.
Okay, so I'm going to erase this. Remember that all of this is recorded, so, and I'm going to leave the graph there. We're going to follow a certain procedure to find the vertex, okay? And I don't know why, but this procedure, again, this isn't a new procedure. This isn't a university procedure. You should have seen this procedure in high school. But I don't know why most students don't remember it and they get confused. And this procedure is called that we're going to complete the perfect trinomial, okay? And this is what we're going to be doing. We've got the function here, y equals x squared minus 2x minus 3. What we need to do to find the vertex is that we need to do a procedure where we can complete the trinomial to be able to find the coordinate h comma k, which is the one that we're doing here. So to do that, we're going to do the following, okay? And follow this procedure, just follow this procedure always, and you're not going to go wrong. And this procedure again isn't new. It's called completing the trinomial. We are going to take the value that's being multiplied here by the x. We're going to take this value here. What value is that? It's the b, right? And what value is that? I want to see if you're. It's you can take it with the sign or without the sign. By the way, I'm going to do it without the sign. So you can just take the value that's multiplying the x. We're going to grab that value. We're going to grab that value, which is 2, and we're going to divide it by 2 and elevate it to the square. This is step 1. What does this give me? It's a very simple mathematical operation. What does that give me?
1.
1, yeah. Without the question mark, it gives me 1. It's not 1. Is it 1? No, it's 1. Okay. So it's 1. Okay. This is step 1. We grab this value, we divide it by 2, elevate it to the square, and we get the 1. Okay. And by the way, bear with me and let's go through the whole procedure so you can see where we're getting at. Once we have this value, we're going to go back to our original equation. And what we're going to do is that we are going to add and subtract that value to the expression. Notice that since I'm adding it and subtracting it, I'm really not doing anything to the equation. I'm not affecting it. If I add and subtract something, the equation isn't affected. Okay, so I'm going to add the value and I'm going to subtract it. Okay, this creates the following. This expression that I've got here once I've added the value is what's called a perfect trinomial. So a perfect trinomial can be factored in the following way. X and the value that I have here, the original value, which in this case is 1, or the square root of that value, elevated to the square. And the sign I'm going to use is actually going to be the sign that I have here in the B, which is -1. And -3 minus 1 is going to give me -4. Okay. This expression that I obtained doing this procedure, this is the expression for the vertex expression of our, it's the vertex representation of a quadratic equation. Okay. And if we remember the definition of the vertex said that the vertex representation said that we had x minus h squared plus k. And remember that what we're looking for here, this coordinate is h comma k. So if I look at the vertex representation, which is this one here, and I look at what I obtained up here, can somebody tell me what are the values of h and k? And it's very important to look at the signs, okay? What are the values of h and k? If I look at this expression here, and then I look at what I obtained up here. What's the value of h?
-1.
-1.
Nope.
-4.
Nope. Again, let's not be random. Let's look at the expression. What does it say here? Minus h. What do I have here? -1. So what is the value of the h?
1.
1. So be very mindful in the models that we're seeing, the signs are very important. They're very important, or else we're not going to get something congruent. So what is the value of the h? The value of the h is 1. What is the value of the k? Following the same logic.
-4.
Correct. I've got a k here, which says plus k, but I've got a -4 here. So this means that the value is -4. Now, is that congruent with the graph?
Yes.
Where should the vertex be? This is like magic. You can be in a party and you can like impress somebody with this. You can be the most popular kids at the party.
Professor,
Yes.
I
Go
have a
ahead.
question on the first step.
Okay, give me just a moment here, Andrea, just to finish this, and then we'll go back and review the whole procedure. Okay, just give me one moment. Okay. The vertex is in 1, And the other value we have here is -4. Okay, so the vertex in this case is going to be 1 and -4. And the imaginary line, that's the orange line here. What is that line called? It's also, we also mentioned it in the PowerPoint. This imaginary line that goes through the vertex, what is it called? It's called the axis of symmetry. And it's important because the parabola is going to be symmetrical to that line. Okay. Now, yes, please go ahead, Andrea.
On the first step where we divide 2 divided by 2 to the square, you said it will always be divided by 2 or by the same number?
That's a very good question, Andrea, to not confuse. It's always going to be divided by 2.
Okay. Thank you.
So that's why I drew it in a different color. So it's the what's in blue is what we always need to do. What's in orange is the number where you're going to be grabbing here. And by the way, notice that it doesn't matter if you grab the 2 or the -2. Do you notice that? Because since we're elevating to the power of 2, it doesn't matter if we take the, so if I would have said that this is -2, which is B, we'll get exactly the same result. Okay, because we're elevating to the square.
Yes, thank you.
Okay, thank you. Okay, questions with this before we move on? Okay, I want you guys to try to do the second one on your own time, and we're going to review it on next Monday. But I want you guys to try to do the second one. Okay. And again, I'm doing this procedure step by step. I'm sorry, I'm doing this procedure step by step, and it's going to be recorded. I'm going to upload this to Blackboard later today. So you can have the whole steps going through, and you can review them at your leisure. Okay, so questions with this one before we move on?
No.
Okay, I'm going to go back to my PowerPoint. So I want you guys to try to do example 2 using the same procedure. Okay, and we'll oops, and we'll review that next session. Okay, we're going to solve it here also. Don't worry about that. But I want you guys to try to do it. The second section of homework task 2 is basically to do this. It's literally you're going to be given an expression, find the intercepts, find the graph, and find all the information. So it's basically what we did there. Okay.
Professor,
now, yes, go ahead, please.
this homework workshop is going to come on the test, right?
Yes, this is going to be, this homework task, the exercises in this homework task are going to be the last topics that are going to be covered in the test, which is going to be homework tasks 4, 5, and 6.
Okay, thanks.
So it's important, Viviana, your question, because of the following. I did a bit of a change because of the feedback you guys gave me. So instead of this is the workshop. So instead of you guys doing the problems by yourselves, the even ones, I'm going to be solving problems here step by step. Okay. So we don't get that sort of confusion there. So I'm going to be doing it here. So this is the workshop that's going to correlate with the homework task 6. Okay. And I'm going to do a few more other examples on today and on Monday. Okay, but with what we're seeing today, you should be able to do most of homework task 6. I don't consider the problems to be that high a difficulty. Okay, now the next thing that we're going to talk about is what are called piecewise functions. What is a piecewise function? a piecewise function is going to be a function that is defined in sections, okay? And that's literally why it's called a piecewise function, because it's defined in pieces instead of being defined completely. And so there's an example there that I want us to look at. A piecewise function is a function that has different sections, and these different sections are defined according to ranges, okay? So how do we represent this piecewise function? Well, first we look at the ranges and we look at the values. So what is the first, and I'm going to draw this in different colors just so we can try to understand it. But what's the first thing we have here in this piecewise function? We have a -1. And that -1 is going to occur for all of the values of x that are less than 0. And notice that we have a less than, not a less than or equal. So what's that going to mean? First, I'm going to locate the -1. So the -1 is right here. So that means that for all of the values that are less than 0, the function is going to be -1. And I'm going to draw a little circle here. And for all of the values of x that are less than 0, we're going to have a -1. Why am I drawing a circle here? Can somebody tell me? Can somebody identify why am I drawing a circle there?
Because it doesn't is the -1 isn't included.
Correct, perfect, Anya. It's less than, not less than or equal, okay? The next part here on the piecewise function is that the function of x is going to be equal to x for x equals 0. So if x equals 0, what's the value of x? It's 0, okay? So that means that here in this point, I have a little circle, and I'm going to fill that one in, which is going to be the value of x for x equals 0. And what is the value of x for x equals 0? It's 0. It's this coordinate here. And then we're going to have, let's see what column I use, this one, x plus 1 for x larger than 0, okay? So we know that x plus 1, right, is a straight line. And what is happening to that straight line, according to what we saw previously about graphs? What is happening with that +1 that we have there?
It will be adding 1 or
Yes, that's like, what's the name of the apple? The name of the apple is apple. What does the +1 mean? If I told you to graph x plus 1, we just did a bunch of exercises.
it's going to shift up 1 unit.
Perfect. The +1 means that it's being shifted up, okay? And so that means that we have a line that instead of being crossing here in 0 is shifted up 1 unit. So we've got a 1 here, and the line is going to go like this. And I'm going to put an open circle here because it's larger than, not larger than equal. So basically a piecewise function is going to be a function that's going to be many functions that are defined as sections. And the whole function is going to be represented like a kind of like a puzzle that has different sections, and each section or each range or each section, I'm sorry, of the domain is going to have a piece or a part of the function. Okay, so these piecewise functions are defined usually f of x, and we've got a bracket here, and we've got the different sections defined here. And what we do is graph or sketch each of them according to the different restrictions that we're given, which are always provided here to the right of the function. Okay. Questions with this one? Okay. I'm going to clear this, and I'm going to go on to the next example. Now, the absolute value of a function. So we've already talked about the absolute value. So the absolute value of a function, or the absolute value of a magnitude, or the absolute value of something, is basically, we're only interested in the magnitude. We're not interested in the sign. And another way of saying this is that if I have the absolute value of something, I'm only going to have the positive part of that. So if I have a function, and this is an example, f of x is the absolute value of x, how would that function be represented? Well, basically it's going to be minus x for all of the x's that are less than 0, and x for all of the x's that are larger than or equal than 0. Or another way of saying this is, if I asked you, if the original, remember how we did the shifts and the shifts, and we did then the reflections, and then we did the compressions and stretches. I always asked you to look at the original or base function. If I have f of x equals the absolute value of x, then the original or base function is f of x. What is the graph of f of x? It's a straight line, right? Now, if I say that I want to find the absolute value of that function, what's going to happen with the graph? What's going to happen is that the positive part, well, the positive part is exactly the same. The positive part doesn't, the absolute value doesn't affect the positive part. That stays exactly the same. What's going to change? The negative part. So everything that's negative is going to be reflected or put on the positive side. So whenever we have an absolute value of a function, we analyze the original function or the base function, and then anything that was below the x-axis, which is the negative y's, are going to automatically convert or turn into positive. Okay. Now let's look at a couple of examples of as how this could be represented. Okay. Questions with this before we do a couple of examples. Okay. Let's look at these two examples here on the bottom. Okay. So let me switch over here to the Blackboard, and let me just write it down. We've got, I'm going to switch over here, and can somebody please tell me the first example? And I believe it says example 4. What does it say?
It's y equal.
Okay, thank you. It says 4. Let me write this down here. Yes, go ahead. Y equals?
Absolute minus 3x plus 2.
Okay. We need to sketch the graph of that. Okay. Now, what are we going to do to sketch the graph of that? Well, first off, I'm going to look at what's inside the absolute value. And I'm going to bring that over here, and I'm going to say that the original function is f of x equals minus 3x plus 2. And I'm going to graph that first, okay? I'm going to graph that first. How do I graph this? Well, first off, I know that it's a line, okay? I know that it's a line. Give me a moment. The original function is a line, and what am I doing with that line? Is it clear that I'm shifting it up 2 units?
Yes.
Okay. So now I've shifted it up 2 units. Is that clear? That's the first part. Is it clear also that it is compressed? I'm sorry, it's stretched by 3, which basically means it's something like this.
Yes.
And is it also clear that it is negative? And what does the negative mean? That we have a reflection. So now the negative means that it's going like this. Okay. So is it clear to everybody that the blue line is the graph of this function here? Okay.
Yes.
Let's just do this. I want to know what the I want to know the value of the x-intercept. I want to know the value of the x-intercept here. Okay. How do we find that? We say that minus 3x plus 2 equals 0. And so this means that x is going to be equal to 3 divided by 2. And this is the x-intercept. Okay, so this value here is 3 divided by 2. Is that clear to everybody? Questions up to this point? The only thing I'm doing is doing the graph of what's inside the absolute value. Okay? Is that clear?
Professor, how did you stretch that line?
The only thing I did, remember that this is a sketch, so the only thing I did is I put it a little bit more closer to the y-axis. Okay, remember that when we do the stretch, it's just it's just a representation of what's happening. If I were to be, I'm just going to take Viviana's question. If I were to be really, really, really strict here and try to do this graph more precisely, a bit more precisely, if this is 1 and this is 2, okay, then that means that this point here is 3. This point here is 3 divided by 2. So if I really, really want to be strict about the stretch, the graph would be, the sketch would be much more inclined. So the line would go something like this.
Professor,
Okay.
I have a question on how did you get 3.5? I mean, it wouldn't be like
Oh, I'm sorry. It's
2/3.
2/3. It's 2/3. Yes, thank you. You are right. I'm sorry about that. 2/3. Yes, thank you. Thank you. Thank you very much, Estrella. You are correct. So this would be even more. Let me do this again, just so we can. Thank you very much, Estrella. You're right. Let me draw this again quickly. So it would be 2/3. Yes, you are right. 2/3. So this means that I'm going to exaggerate this a bit. This is 1, 1, 2, 2. Two-thirds then would be around here. Okay, so the line of the graph would go something like this. Okay, so that represents the stretch much more, because remember that the stretch makes it go closer to the y-axis. So thank you very much, Estrella, for that catch. So this would be the graph of the blue of what's inside the absolute value. Okay, is that clear to everybody?
Yes.
Now let's apply the absolute value. So now what we want is the absolute value of that. Okay. So we've already identified the original graph. So what is the absolute value? The absolute value is that, again, the positive part is going to stay positive, and the negative part is going to convert into positive, or it's going to reflect. Okay, so the pink graph would be the function that we were looking for, which is the absolute value of the function. Okay, so in the case of the absolute value, once we have the original graph, the absolute value is only going to, the negative part is going to turn positive. The positive part is going to stay exactly the same. Okay, questions with this one before we move along? So what we're trying to do right now is we're trying to link up what we've learned up to this point. So remember that we had already talked about what a function is, what an absolute value was. We talked about intercepts and graphing or sketching graphs. And now we are relating all of this with regards to linear, quadratic, and also absolute value functions. Okay. Now questions with this one before we move on. Okay, so what I want you guys to do is we're going to continue with these examples on Monday.